So we're back. And Chris, thank you so much for joining us. I can imagine you guys are super, super busy at the minute with everything going on. So yeah, how are you doing?
Pretty good, pretty good. Thanks for having us. It's
Yeah,
glad to talk
absolutely.
with
Thanks.
you and also your listeners.
Yeah, thanks for joining us on the round table last week as well. Thanks for co-hosting. That was a great episode. And I think I think what you guys are doing is one of the most interesting kind of cross sections between a couple of industries, despite it being wrapped up in robotics itself. But what I think a lot of listeners will probably get great benefit from with this conversation is just kind of like if we just start off with the current landscape of the robotics sector. So a lot of people will be seeing some of the really interesting product videos coming out, and everyone knows of Boston Dynamics from back in the day. And I don't know what's happened with those guys recently, but it seems like there's a lot more labs out in the east coming and doing extremely great jobs. But like, what's the current landscape look like in robotics, just to kind of give people a bit of a primer?
Yeah, I think this is really interesting. Question. I think we're actually under the interesting transition period. On a surface side, I think the hype looks very ready, right? You see humanoid folding laundry, cooking, doing warehouse tasks, manipulation objects, all, very polished demo. And to be fair, embodiment side is improved a lot. The hardware is no longer science fiction. The cost performance curve is getting much better, and a company like Unitree are becoming a serious commercial player. But if you look at what is actually deployed at scale, we are still mostly in structured environment, right? Like factory, warehouse, logistic, things like this. So, there is a still big gap between demo and deployment. A demo only have to work once in a controlled setting, right? A real robot has to work thousands of times with changing lighting, messy objects, sensor noise, human interaction, all these things. So my view is that robotics has not reached its GPT-1 moment yet. For a language model, once the transformer emerged, the path became much clear. The industry learns that if the skill in right architecture with enough diverse data, you start to see very visible capability gain. Robotics do not have that consensus yet. The biggest bottleneck or the open question is that it's not just what kind of model architecture we. The question is what data is we actually need and how much of it to capture real physical interaction. Language model already existing on have already exist in the internet, right? But physical interaction data does not exist in on internet scale. We need data to capture perception, action, context, embodiment, failure, recovery, long horizon behavior, right? So to me, the state of robotics today is hardware is getting ready, demo is getting impressive, algorithms are converging, but the data foundation for physical intelligence is still missing.
So if we're to give it, so everyone listening to this will have almost certainly used a product from OpenAI or Anthropic or Google, and where let's timeline it with like a GPT. Like where are we? Is it GPT-1? Is it pre that? Like is it two GPT-3? Like these kind of when there was this kind of seismic shift. Like where are we on that timeline to kind of give some reference point?
I think that's the good comparison. I think we're still pre GPT-1. Let's go back to 2018. That's the emergence of GPT-1, right? And with GPT-1, we know transformer works. That GPT-2, I think it used 500 hours, 5 million hours for GPT-2 training. But for GPT-3, probably they need 15 million hours of context, right? And for now, I think the usable data for general robotics intelligent training is less than 1 million. So it's a long way to go. And the physical world is 10 times diverse than the internet than the language field, right? So we probably need more than let's say 1 million, 100 million or 1 billion hours of useful data. So that's the huge gap.
Wow. So like how do we actually get there? Because it feels like a bit of a chicken and egg situation where the robots need the data, and then the data isn't actually needed to train the robots. Like this seems like I think a huge undertaking is like a ridiculous understatement. Like, how do we actually get this information in? And like, what does that information look like? Does it need to be extremely accurate? Can it be noisy? Like, what does the data landscape look like? Because that's the obvious bottleneck here.
Yeah, I like this. I mean, the chicken egg question. I think this is very real. You need better data to build better model, right? But you also need better robust deploy in a real world to generate the highest value of data. In the long run, uh, the best data definitely will be probably come from robots actually doing real work because that captures the model's own behavior, mistake, recoveries. But we're not at the large scale deployment yet. So the question today is, how do we scale diverse physical AI data before robots are everywhere? Our answer is to combine multiple data pipelines because we believe that the future is like a hybrid training. Ego-centric data give you human-world interaction. Simulation data give you a scalable robotics trajectories and controllable task variation. Teleoperation give you action-grounded demonstration. So none of this is perfect alone, but together they can bootstrap the system. And that's why we feel like the data flywheel is the key starting point for now. So we do not wait for the perfect data source. We build the infrastructure to combine imperfect complementary data sources at scale. I think that's the key problem for the whole industry for now.
Yeah, and so if we think about if you think about the sourcing of the data and the what I'm seeing, and you're going to have a unique perspective on this, so maybe you can educate me here. Is this one of the reasons that you're seeing a lot of the big AI labs either try to push towards wearables, whether that be glasses, or I know OpenAI have kind of worked with Johnny Ive on this like wearable device, but is that just to collect more spatial data? So like the Meta Ray-Ban glasses, is that all useful data for robots, or because it feels like there's a big push? There's been a few stop starts. Like some people say the glasses aren't very comfortable to wear for a long period of time. But is that kind of like a push towards collection of that data?
Could you repeat the last part again? I'm sorry.
Yeah. Yeah. So like what we're seeing with I know Meta glasses are pushing this quite hard, and OpenAI and Johnny Ive have been working on a wearable device, and Google Glass and the Apple headset. Like there seems to be a push towards wearables, but I think if we're talking about this like in a data collection perspective, is that the reason that these big companies are pushing towards this and like trying to kind of get these to market very very quickly? Is that like a really good data collection source, and isn't it just like it's definitely not a fashion accessory, it's like a huge data collection pipeline for these frontier labs?
Yes, I think all these devices you mentioned are the good uh, handable wearable devices for data collection, especially for egocentric data. And the one you mentioned, the Meta Quest, right? Someone used that to collect the real world detection and use that input to train a model. DeepMind also asked the data vendor to use 6 camera headband or some motion capture devices to capture the whole body control signal. I think it all works. It's just the one way of data collection. But the key message behind it is that the whole industry understand that we need as diverse data as possible. We need the data to coverage as many uh, diversity scenarios as possible. That's the prerequisite for model generalization.
And how are you guys thinking about this, and like what's the unique angle of data sourcing, collection, training that you guys are taking the approach with Axis Robotics? Because we've been doing a bit of digging internally. Like, I think you guys are super interested in it. But I think the angle that you guys are coming from is a little bit different to what we've seen previously as well. But I'd love for you just like the floor is yours, just to kind of like give a high level of how you guys are actually operating.
Yeah, definitely. I think on a high level, our vision is always that we want to create generate as diverse as possible to accelerate the process of emergence of physical intelligence. And our wedge is robotics data infrastructure for sure. But the bigger vision, as I said, we want to build a global data engine to accelerate it. A global is important because robotics data needs are not static. Where models company need today might be simulation trajectory for manipulation, or ego-centric data for world model training. But probably later they might need a DAgger style correction data for post-train or failure data, evaluation data. We don't know, right? Probably embodiment specific post-train data. That would be the chance. So we do not want to lock into one data modality. Today we have a distributed contributor and a better network that can support multiple data pipelines like simulation, ego-centric, DAgger style correction, and potentially UMI style manipulation data going forward. That flexibility matters because the diversity requirement for physical is extremely high. It spans different industries, workflows, object categories, environments, human behavior, and robotics embodiments. I just had a call with OpenAI, and what they ask is that the data need to cover 300 different categories. Imagine that some country may not have 300 categories of industries, right? So how can we achieve that? A few lab environments or the few factory partners are not enough at all. So right now, for us, we have around 2 million simulation data trajectories, 100,000 hours of ego-centric data across more than 13 categories and 80 subcategories. We're adding roughly 400,000 simulation data trajectory per month and 30,000 hours of ego-centric data per month. But that's not enough for sure. And what OpenAI and what NVIDIA and DeepMind need is more than 1 million hours of data for each half a year. But we do not want to be just a raw data vendor. So over time, we value the value will become the whole infrastructure. It's like from task generation to contributor coordination, quality control, data processing, metadata, evaluation, API, all those things, right? So the wedge is data, but I think for long term, it's a system capability.
Yeah. So is this similar to how you can, as we talked about GPT-1, GPT-2, and now you're starting to see if those were the kind of like flagship models that everything was built around, and now you start to see things like Harvey AI, or you start to see things that are extremely bespoke to a certain use case, and it just continues to get trained. One might be in biotech, one might be in assembling, one might be in collection, one might be for, I don't know, the shop floor for Amazon and big distributors like that. So you kind of like have to start with the bulk core models, and then, as you say, when specific companies would eventually come to you guys and be like, we need this for robotics, we need this for we need this for like biotech, we need this for collection, blah 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 blah. So you kind of have to get the good core data set and then fine tune accordingly to what the process is for the specific company. Is that correct?
Yeah, totally. I think you are the visionary. I mean, what you are imagining is like a 5 years from now, because when we have a general purpose model, we have a capability to do some broader tasks. But after that, we need to fine tune or refine it based on specific requirements, like you mentioned. It's just like when we have LLM, we can do chatting steps, right? But when we have an agent, we need to train the agent specifically for a specific task, either for coding or for online shopping or some personal assistant, whatever way you call it. But it needs time. But for now, I think the in purpose is whether we're gonna take general thinking or vertical thinking. I think the LLM told us we need definitely to take general thinking. We need to have a general purpose model first. Then we can do some post-train things for specific tasks.
Yeah, totally agree. So how do we effectively get to the 1 million hours every half a year? Like how do we actually physically do that? And I know that you guys have got some really cool incentive mechanisms, and I think it's very, very kind of forward thinking, and a lot of people won't be seeing it that way. But from someone who likes to just cover general tech and what's happening at the forefront, I think there's a collision of multiple industries here where there's a lot of really cool moving parts that make a ton of sense. But yeah, can you talk people through that? And is there anything for people to be able to do themselves if they were wanting to get involved or contribute or anything like that?
You mean for all these retail user, all this, your listeners,
Yeah,
for
yeah.
example? Yes, I think absolutely. And actually, this is already how the industry is moving. If you look at the ego-centric data, a lot of data collection today involves, real people in the real environments, like using your iPhone, using head-mounted camera, smart glasses, gloves, and all these devices you mentioned, and to capture how they live and work. The reason is simple. If we want robots to understand the physical world, they need to understand from how humans interact with it, right? Humans are still the best resources for physical intelligence. Uh, we now we know how to open the drawer, or pick up the objects, clean the table, right? And a lot of this knowledge is now written down. It's lives in behavior, and teleoperation is another version of it. When a person teleoperated robot is basically him teaching the robot what to look at, where to move, how to grasp, when to slow down, and how to recover. And at Axis, we believe the same pattern will apply to simulation and the DAgger pipeline as well. We bring human into the loop because human decision, correction, and variations are extremely valuable. Different people solve the same task in a different way, and that diversity is exactly what robots need. So yes, all this retail user, your listener, can help through ego-centric data, simulation tasks, teleoperation, annotation, or feedback valuation loop. The core idea is simple. Robot intelligence will not be built by a few researchers in one lab. It should be built from millions of human interaction across many environments, professionals, and tasks. That's why we're seeing that robotics intelligence not should be built by a few, by all.
And who do you, is Unitree at the center of that with their G1s? Like, are they? Is that what everyone's kind of getting their early iterations, and is that what everyone's experimenting on currently? Are there any other kind of big players in that space from the hardware perspective?
Yeah, I think the good strategy Unitree applied previously is that the actually sponsor a lot of cutting edge academia research. So
Okay.
the most of the labs worldwide are using Unitree's hardware for their experiment, and most of the demo are shooting on Unitree G1. So they are
Gotcha.
super adaptive, right? And they are super stable. So the standard is all setting by Unitrain G1, and some of the sort of the real world adoption data are also captured by Unitrain G1, and it's
Okay.
really hard to retargeting or transfer to other robotics hardware specifically. So that's the front run advantages. I think that's also the reason why they got huge revenue and also profit. I think that's the things they did pretty well. And I think another thing they did super good, super cool is that they start to talking about whole body control 2 years ago. So they have the
Mm.
whole stack and also the data collected from their environment to that hardware to learn how to control the whole body, not only the locomotion, but also locomotion plus navigation plus the manipulation. That's the advantages.
Well, and what do you think like the most immediate industries that are going to benefit from this are, and like what are the most far out, maybe a longer time duration, but would have like immense benefit, you know?
Uh, you mean which industry will be benefit by robotics or by
Yeah, so
the
which
embodiment
ones
itself?
are, yeah, so which industries are more, which industries are ready to get extreme benefit from robotics in its current state or maybe the next iteration, and which ones are quite far away? So like for example, is we see a lot of Amazon robots flying around the warehouses picking up certain items, and is like that more delivery and logistics kind of already there? And then maybe we talk about biotech, or even kind of like remote surgeries, you know, like for like you see a lot of these
Got it.
like
Got it.
so like which ones are nearly ready and which ones like are quite far away?
I think in the near future, the manufacturing industry is gonna be fully rebuilt by robotics
Mm,
because they've already adapted a lot of industrial automation things, right? Like all this,
mhm.
European companies, like German companies, but they are not the learning based solution. They are the pre-programming. Like for example, we have a client in China, the car company. They ask us to help them to deliver a learning-based car component sorting solution. They have 2,000 different car components, and for now they're sorting it one by one by their workforce, real people. they want to sort of, cut 1,000 people for that. But how can the robot, how can the arm learn different new components? So we help them to collect all this data. We help them uh, uh, to deploy all these components in a simulation environments, then do that specific task, then collect all this data, then train a sort of a general purpose model for their solution. And I think after we did that, their factory is more like a black box. They don't need any real human to do that things, and they can replace the whole manufacturing pipeline. And that's the huge that step forward.
And
that could be applied to any manufacturer.
Yeah, and these manufacturing companies that might be like, they might be slightly advanced, but they're not along the lines of automation and robotics. Like, are they quite data rich? Like, is there a lot of like insightful information from like those legacy style manufacturing companies that is useful, or like how does that look?
Yeah, I think they do have a lot of, legacies, like the data, especially the processing data, how their people or how their existing robot arms are working in a real environments, but they just haven't collected them or trained them properly. So what they need is like a sort of a model capability. And how does the model capability comes from? I think it should come from, as we said previously, the general purpose model. We need to distill it from it, and we need to target it and refine it based on the specific environments. So I think they have all the projected they've already had for the last 5 to 10 years, because they are the real business. But what we need to do, or what the embodiments can enable them, can empower them, is that is there any high-level intelligence, perception, action signal, or the coordination between all this can be used in a real working pipeline.
Gotcha. And what's the kind of, is the industry converging onto a certain open source model as like the base model for the training of robotics, and then fine tuning? Like what are people currently using as the underlying LLM for training, pre-training or post-training? Like is NVIDIA winning? Like who's winning on that front?
Yeah, good question. I think the algorithm and model things are converging. We have two different types of a model, right? A VLA and a word model. VLA basically we take the LLM language model as the basic foundation model, give more sense on precision and also the language semantic sets. But we just need to collect the action signal, either from human or the real robot, either in real environment or simulation. And for word model, I think that's, have a bigger picture, because the word model company want to take word model as the foundation model, similar as LLM. They take word model as the understanding of the whole world. And that's why they need tons of real world detection data. They want to build a foundation model from scratch that can understand the whole world, do some special reasoning, all the stuffs. So I think that the two fronts, we don't know which one will win. But I think in the future, probably the fusion, it's like a fusion solution. We need to combine the advantage of both, because the VLA model give you more action signal, and word model give you a more, understanding on the whole world, how you interact with it. But I think, the model training pipeline are converging. The only thing that haven't converging is data. So that's why we feel like this is right time for us to, jump in as the data company and serve out the smaller company, or even emerging with all the smaller company to help them improve the performance of the existing model.
And would you guys ever, and I know this might be a long time away, but would you guys ever have aspirations of doing any like consumer hardware or relatively like general hardware, or are you just more interested in helping and enable other companies by what you guys are doing on the data side?
A good question. I think we, in the near future, we don't want to do our own hardware, because there are three kind of players in this industry: hardware company, model company, and data player. I think all the three could work with each other more strategically. not just as a supply or demand, but more emerging. So we tend to collaborate with hardware company and model companies more closely and offer our capability. Now, tap into their business, because for all each business, they have a lot of, underwater things that we need to care about for data, not just collection, but also processing it, but also how you run a system that could, fulfill all this task effectively. And for hardware company, they also have their specialties. So I don't want to, tap in their specialties, but focus on ours and create more value to them. Not just the data or the single trajectories, but also the whole solution that could, improving with them together.
Yeah, awesome. And so what's coming in the immediate future for Axis? Like, what are you guys focusing on primarily? What's taking up the majority of your time at the minute? I know you guys are just coming onto market and starting to make a splash, but yeah, what can people expect over the next, I don't know, 6 to 12 months?
Yeah, I think the couple things that people can expect for us. We just released our roadmap for the next half a year and a year. I think there's three things. In a bigger picture, we're gonna definitely scale and also do more commercialization things. But there are three things we wanna, tap on. One is, as I said, we want to have as diverse data as possible, and we've already have the pipeline and capability to generate the number of data, as I said previously, but we want to enlarge it probably 2 to 3 times. And we want to have more data pipeline, like I said, probably teleoperator data and ego data to give us more, broader coverage of what we call data diversity coverage. And the other thing is definitely the global contributor or vendor network. As I said, there isn't any single vendor can fulfill all these tasks. So we need to cover with all different regions geographically, and also all different categories, players, so that they can share the same vision with us. They can be a part of the ecosystem. We want to build a truly open ecosystem that we can enroll in all different kind of contributions, then turn them into a model training ready data or model training ready assets. That's the systematic building. That's how we build an organization that could run this effectively. And third is definitely commercialization. We're now sell data trajectory and a solution to clients in China, specifically on robotics hardware side, and also clients in Europe for model, and also in the States for model for sure. But we want to, enlarge our revenue for 3 to 5 times in the next year. Probably we can enter into the preferred vendor list for the top tier model company and Omega 7 in the state. Yeah, that's basically the three things that we want to build. And at a very foundation, we are building is not the data, the labor. Is like a foundation. It's like infrastructure to serve all.
Yeah, awesome. Honestly, the as I say, it feels I sometimes struggle to understand like how early this is, and I think the GPT-1 or maybe even earlier references like really good benchmarkers. When you look at these things, quite a lot of the time that you spend looking at it, and you kind of live in this echo chamber, you don't realize like sometimes how early these kind of things can actually be in comparison to what's happening in the rest of the world. And I think Twitter and X definitely shows like and creates this kind of echo chamber and bubble of like a walled garden. And
Yeah.
it's sometimes very difficult to understand like where we actually are in the life cycle of it. So like I really appreciate you coming on and kind of saying this is super early, but the opportunity is enormous. And yeah, if there's anything you guys need from us, you know where we are, and love to have you back on in maybe say 6 to 12 months and see where you guys are at. And yeah, thanks so much for joining us.
Yeah, super exciting. Love to come back after 6 months. We can review all this progress, either from us and also the industry. I think the next 12 to 18 months gonna be a huge opportunity for the whole industry. We could expect a general purpose model. We could expect a more diverse type of hardware in different industries. So I think it's super exciting.
Amazing. Well, thanks so much, Chris, and thanks for everyone for listening. We will see you on Wednesday, and yeah, take it easy. Over and out.